Okay. In this presentation, I would like to introduce our new result in some kind of combination between AI and cybersecurity. This work is done by my PhD student, Miss Bao Ngoc. It's about a GAN-based approach for password guessing. So we will talk a little bit about the password guessing overview, and then about the GAN-based passwords approach, and some experiment result and a conclusion. So as you know, the password recovering is quite a hot topic in cybersecurity. It's there are many kinds of tools using for password guessing, password recovering, like John Ripper has cast, Laser Soft, Trinity, and so on. So the idea of the password guessing or password recovering is when we see at the passwords hash function, we can somehow guess the password by using the password dictionary. In order to guess passwords, we use we need some password representation method, and a big enough dictionary in order to we can compare the password as the hash function password with each record in the records in the dictionary. And what we are doing now, we try to create the passwords, try to create the dictionary of the passwords, because of the space of the passwords is very huge. So we try to create a dictionary that can cover the real passwords. And with this, we surveys and found that there are several approaches in order to guess the passwords. So they can use some types of brute force. So, and the second one is rule based. Rule based means that we can generate password based on rule. For example, we can tell machine that we would like to generate a password with maximum 8 character, which first one is low case, second one is uppercase, and something and so on. And the next one is probabilistic methods. They can base on some. The first one is a probabilistic context-free grammar, and also people use Markov model base. The next one is on the neural network base. There are some quite common method like fast learn accuracy, and PassGAN is based on generative adversarial network, and PassGAN actually based on the CNN base. And the next generation of the PassGAN is A-PassGAN. It's based on RCNN. The fifth group of the password guessing approach is called the hybrid methods. It's a hybrid model between the brute force or rule-based with AI methods, like a brute force with rule-based or brute force with like between probabilistic with and some machine learning model like LSTM or LSTM. And in this work, we focus on the generative adversarial network base. So we focus on the PassGAN. It's the idea of this method is based on the two blocks is a generator and a discriminator. The generator can generate fake passwords, and we have a real password. We train the system by comparing between the fake password and the real password using a discriminator in order to generate a password. And as you see on the slides, the last function of this training method is based on the PassGAN. And in the real passwords, in order to compare with the fake password, we use one hot representation. And the problem here is the fake password is generated by the machine. So it's the GAN space is generated by the distribution. So so as you see, the fake password is not really like one hot, because it's
anh phải cạnh tranh nhau bằng người thôi, năng lực thôi.
For example,
hello, someone please talk.
Okay.
Seems okay.
So people trying to use three solutions. The first one is they're trying to use some reinforcement learning, and the second one is trying to using autoencoder to represent for representations the passwords, the real passwords. And this third one using some KFC using the continuous approximation of sampling operator. And in our work, we propose two methods based on the combining with autoencoder and using continuous approximation of sample operator for representations of real passwords. And then the first one we call the smooth PassGAN, S-PassGAN. So the idea here is we try to representations of the real password by autoencoder in order to get the more smooth representation of the password. So here we just put the autoencoder between the real password after the real password, and after that we got some kind of new input for the discriminator. And in this method, we just change the loss function. We change the loss function. If you mentioned that before, so here's the D. So I can go back here. So the first element, so D of X, and the next one is D of AEX. So we just change X by the autoencoder of X. So we try to use some kind of smooth representation of the data of the real password. And the second approach of our work is we use we call this GS-PassGAN. It's based on some Gambian max trick. It's some kind of the new presentation of the real passwords. And with this presentation, we can get some kind of the it's also smooth representation, but it's based on the Campbell sum-up relation. We call Campbell sum-up relation. And this form, if the PassGAN feeds output at a softmax vector directly to discriminator. So instead of that, one-hot vectorization due to non-differentiable upsampling form, multi-nominal distribution.
Hôm nay thì trò tiếp.
And here is the experiment result. So we use 4 datasets: RockU, MySpace, HBB, and LinkedIn. We use the first dataset for training and 3 remain datasets for testing. The number of passwords in each dataset is quite huge. For example, for RockU, we have nearly 32 million number of passwords. And the experiment set up as follows. So the model are training with RockU, as I mentioned before, and correct the performance. So the guessing performance is evaluated with in other dataset. For each model, we use a billion password, the dictionary for veneration. And we combine with the tool in order to evaluate the result. To new password. And we use a number of match password between the dictionary and the test set. And here is the result. So as you see, the second column is when we use the hashcash only. This is quite common tool for people in cybersecurity. If we use only hashcash, so the result is nearly 19% of the matched password with the model. But when we combine with our proposed model S-PassGAN and GS-PassGAN, so the result is quite better. So we can improve the results from 19 up to 23%. So in the conclusion, so in this work we propose the 2 improvements. We call GS-PassGAN and S-PassGAN to deal with discrete nature text in PassGAN. And the experiment at the you see before, so that's our model is quite outperform a baseline model in terms of. In future work, we will focus on explore strategy, suitable temperature, reduce the variance of gradient of the Gumbel max trick approximation. So thank you very much for listening.
Mình trúng từ chỗ nào chứ?